Hi everybody, this is Rob Swatsky from the York campus of HAC, and in this podcast we'll review the measuring of pulse and blood pressure. Pulse is a pressure wave created by the alternating expansion and recoil of elastic arteries that occurs after each contraction of the left ventricle. The arteries nearest to the heart have the strongest pulse, which then weakens in the arterioles and is absent in the capillaries. Pulse can be measured in the more superficial arteries located near the body surface that can be compressed against a bone. Some common pulse points where pulse rate can be measured include the radial artery of the wrist, as shown here, the brachial artery of the upper arm, the common carotid artery of the neck, the facial artery of the mandible, and the superficial temporal artery near the ear. In the lower body, the femoral artery of the thigh, the popliteal artery of the posterior knee, and the dorsalis pedis artery of the foot. Resting pulse rate is usually similar to the resting heart rate, an average of around 70 to 80 beats per minute. A rapid resting heart rate or pulse rate exceeding 100 beats per minute is called tachycardia. A slow resting heart rate or pulse rate below 50 beats per minute, often seen in endurance athletes like marathon runners, is called bradycardia. Blood pressure is defined as the pressure in the arteries that is produced by the contraction of the left ventricle during systole, as well as the remaining arterial pressure when the ventricle is relaxing in diastole. It is typically measured in the brachial artery of the upper arm using a blood pressure cuff called a sphygmomanometer. This consists of an inflatable cuff attached to a rubber bulb that one pumps to inflate the cuff, along with a pressure meter that reads the cuff's pressure. The arm where blood pressure is being measured should lay at the same level as the heart. The cuff is then inflated until the brachial artery is compressed and the blood flow stops. A stethoscope is then placed on the brachial artery below the cuff, and then the cuff is slowly deflated. As the artery opens, blood begins to move through the vessel, which creates the first sound heard in the stethoscope. Here we see on this graph showing pressure in millimeters of mercury over time. This is the location where the first sound is heard, as the pressure in the cuff is gradually released. These sounds are called the Korotkoff sounds. The first sound represents the systolic blood pressure in the arteries immediately following contraction of the ventricle. The cuff is then further deflated, and the sounds eventually become too quiet to hear through the stethoscope. The last sounds heard through the stethoscope correspond to the diastolic blood pressure, which is the pressure generated by blood remaining in the arteries while the ventricle is relaxed. In an adult male, the normal blood pressure is 120 millimeters of mercury or less systolic, and 80 millimeters of mercury or less diastolic. Young adult women usually have a blood pressure 8 to 10 millimeters of mercury less than young adult men. Blood pressure is a little lower than 120 over 80, the systolic over the diastolic number, may indicate good physical fitness. Pulse pressure is the difference between the systolic and diastolic pressures, normally around 40 millimeters of mercury. It's a useful number that gives some insight into the overall state of one's cardiovascular system. Systolic pressure is normally 3 times the pulse pressure, while diastolic pressure is normally 2 times the pulse pressure. This relationship can be expressed as a ratio of 3 to 2 to 1.